so in this lesson we're going to talk about equations of circles. And first we're going to derive how we came up with the equation of the circle using Pythagorean theorem. Again, this is one of those things we need to show you, so it will help you kind of understand maybe where these equations come from. It kind of ties everything together. So we're going to say h and k is the center of the circle. And then the radius r, which is drawn, and then the endpoint of that radius is x, y. So kind of how they derive the equation of a circle is they found the distance of the radius. Alright, that kind of started where we get our equation. So again, to find distance, we use the Pythagorean theorem. Okay. And so in order to use the Pythagorean theorem, which is a squared plus b squared equals c squared, we have to draw a right triangle just like we did. Go ahead and do that on your paper. And label your sides. Well, the side across from the 90 is always our C. And then it doesn't matter, this could be our A and that could be our B. Normally what we would do is just count the distance. The problem is we don't have numbers, they just gave us letters. So it might help if we could kind of draw our own triangle that gave us numbers. I'm just going to make up points just to get a good visual. I'm going to say this is side 2, and this is 8, 2, and this is, we'll say, this is 8, 7. Just made up numbers. Turn that on a point. Well, to find distance, and then you can count, or if we're going horizontal, like the x-axis goes horizontal, you can just subtract the big distance from the small. So you can do 8 minus 5, and that gives you 3. That gives you the distance. Well, we can do the same thing here, except our distance is going to look more like an equation. So we know this point right here, it's labeled hk. We know this point right here is labeled xy. We just need to find this corner point right there. Okay, well, if you notice how this, I'm going to highlight it in green, this green corner point, is in line with this blue point right there. So they're going to have the same exact x value because they're in the same x spot, one's just a little bit higher than the other. And to figure out the y value, well, we're going to look at the point next to it. That guy right there, this red one. Okay? They're in the same y spot, one's just a little bit further over than the other, so it's going to have the same y, so it's going to have k. So the same process that we did on the bottom, where we did 8 minus 5 to get the distance, when we get the horizontal distance, we're going to do the same thing. We're going to do x minus h, and that gives us our a. Okay. It's a little weird because it's letters, it's not numbers, but it's just a process. So if you replace those letters with numbers, it will end up working out. Okay? We're building an equation. Well, if we wanted to find, go back to this bottom triangle, and we wanted to find the vertical distance, well, vertical is always dealing with the y. So you would subtract the big y minus the small y. You would do 7 minus 2, and that gives you 5. Well, we would repeat the same process with this triangle. Just like we did here, we did big y minus the small y. To find our b, we're going to do big y minus our small y. So we're going to do y minus k. And then our c, we said, is acting as the radius, which is r. So it'd be c squared. And that's how you come up with the equation of the circle. You don't necessarily need to sit down and memorize the process and where it came from. That's just something I need to show you to kind of help you understand why h, y, k were this formula came from. We just need to focus on how we actually use it. Which we're going to talk about here in the next section. So look at the next section. Here again, the equation of a circle is just x minus h squared plus y minus k squared is equal to the radius squared, where the hk represents the center and r represents the radius. So literally all you have to do is just take whatever the x value of your center is, plug it in here. Take the y value of your center, plug it in here. Take whatever your radius is and square it. That's all you have to do. Also might notice how the h here is positive. Well, when we plug it in, it turns negative. Same with the k. The k here is positive. Well, when we plug it in our equation, it turns negative. So that's something you also have to pay attention to, the sign switch when you plug it in. So look at this first example. We're given the equations of the circle. We just need to find the center and the radius. Okay, so for n, I'm going to make my point because I know I need to find the center. Draw my r because I know I need to find the radius. Go to the parenthesis with the x. Inside we have a negative 5. Well, when we take it out of the equation, the sign's going to change. So it's going to become a positive 5. And the sign switch when you put it into the equation. The sign also switches when you take it out of the equation. Here we have a negative 2. Change the sign. So the y value of our center is positive 2. To find our r, all you have to do, because in the equation it's r squared, well, we just want r. So you square root that back number. Square root of 25 is 5. Go with B. We want our center. We want our radius. And then go to the parenthesis with the x. It's a positive 4. Change the sign. Becomes a negative 4. The parenthesis with the y has a negative 1. Change the sign. Becomes a positive 1. And to get our r, we just square root that back number. So root of 100 is 10. And then for C, you notice we're not adding or subtracting anything like a and b with the x. Now this had x minus 5 and this had x plus 4. This is just x squared. So when that happens, it's always 0. So if it's just x squared, if it's just y squared, then it's always just 0. And if we go to the parenthesis with the y, it's a negative 3, change the sign. Square root that back number to get your r. Square root of 1 is 1. Okay, so that's kind of going backwards. You're given the equation and we're trying to find the pieces. In this next section, we want to write the equation of a circle, and it has the center 5, 0, and the radius is 7. So go ahead and I like to write the bones. Skeleton. Okay. This is always going to be an x. This is always going to be a y. Every time. Set it up that way. Look at your center. Here we have a positive 5. Well, when we write it in our equation, the sign's going to change, so it's going to become a negative 5. Here, our y value is 0. Well, right now, just write it as minus 0. And then you take whatever your radius is and you square. So our radius is 7, so then we square 7. The thing is, you can't leave it like this. You have to clean it up. Well, in this parenthesis, that's just going to say x minus 5 squared because we can't combine x and 5, so just leave it. In this next parenthesis, you can combine y and 0. Y minus 0 is just y. Okay, that's good. And then you have to square your radius. You can't just leave it as whatever the number is squared. You need to clean that up, simplify it down. 7 squared is 49. There's the equation of that circle. Can't leave it like that first one. A lot of students just go straight to this blue one. They know to change the sign. They know it's 0, so I'm just going to put y squared. And they just do the radius squared in the calculator and write it down. That's totally fine. But if you need to do this first step, go ahead. This next example, again, we're going to write an equation of a circle in standard form with a center -5 and the diameter is 18. Go ahead. Right there, skeleton. This is x, this is y. X value is a -7, change the sign to +7. Y value is a +5, change the sign to a -5. And then all you have to do, you have to be super careful. It's tempting to say 18 squared, but it gave us the diameter. So when it says diameter, remember that's half the radius. So you just have to divide it by 2. Our radius is 9. And 9, you can plug in 9 squared. Not 18 squared, because that's the diameter. Gotta cut that in half. Clean it up. That's just going to say x plus 7 squared. That's going to say y minus 5 squared. And 9 squared is 81. You have to remember to square that radius. You just can't leave it as 9 squared. Again, just change the sign of the center, square the radius. Put in the numbers in the right spot. Okay. On the back, if you flip it over, this should be example 4. Ooh, out of order. We're going to go ahead and graph this circle. It's a lot easier than what you think. Similar to what we did in that first section, we're going to write the center and figure out what the radius is. So again, go to the x. There's a -2. Change the sign to a +2. Go to the y, it's a +4. Change the sign to a -4. And then you get the radius, you just square root that back number. Square root of 36 is 6. So to graph, all you have to do is plot the center. Be careful, we're going by 2s. So there's 2, -4. And then count the radius. And again, be careful, we're going by 2s. So if our radius is 6, you're going to go 2, 4, 6. And you're going to do this in 4 directions. You're going to count 6 to the right. You're going to count 6 to the left. 2, 4, 6. You're going to count 6 up. And you're going to count 6 down. Okay? I know it doesn't necessarily look like a circle, but all you have to do is just connect these points in a circle pattern. Please be neat as you possibly can. Some students like to take their compass, put their needle on the center, open it up to one of the endpoints and make a circle. Just freehand and draw it, that's okay. Just be neat, don't make squares. Make sure you're connecting all the points. Don't have sloppy circles. There you go. Just write the center, write the radius, plot the center, count the radius in those 4 directions, connect those outside points in the circle. We look at example 3, we want to write the standard equation of a circle. So it's kind of like going backwards from what we did in that last problem. So we want to find the center, and we want to find the radius. Well, the center is this point right here, is 0, -4. And then you get the radius, again, all you have to do is count. You can be careful, we're going by 2s again. So that would be 2, 4, 6. So we write it, and then we have our bones. -0, change the sign, +4, square your radius. Well, x minus 0 is just x, so we write it as x squared. We're not going to change y plus 4, so we can't combine anything. And then 6 squared is 36. There you go. You write your center, you count to get your radius, and just write an equation just like we did on the front. Just change the sign, square your radius. In this next example, we have to figure out at the point 1 radical 3 lies on the equation x squared plus y squared equals 4. And we want to show algebra take 1, plug it in for x. You take radical 3, plug it in for 1. And then you just simplify it down. Well, 1 squared is 1. When you square a square root, that's like doing the opposite. So it just cancels out the square root and the square, and you're just left with a number underneath. And then you're going to do 1 plus 3, which is 4. If you get the same thing on both sides, that means that point lies on that circle. So your answer is yes. If you don't get the same thing on both sides, so let's say you got 7 equals 4. Well, 7 doesn't equal 4. So your answer would be no. Okay. The same thing on both sides. Yes, that point lies on the edge of that circle. If you don't get the same thing on both sides, then it's no. This point does not land on the edge of that circle. Last example, we want to find which of the following does not fall on that circle x squared plus y squared equals 169. When you're given these type of problems, you just have to go through and guess and check. One of those is the correct answer, you just have to figure out which one it is. So take this first point, plug it in. Well, negative 12 squared is 144. Negative 5 squared is 25. And when you combine those, you get 169. Is equal to 169. So we want one that doesn't fit. That one does. So we're going to cross it off. We got the same thing on both sides. You can also cross D because those are the same numbers. It doesn't matter if they're flip-flopped. It doesn't matter if they're negative or positive, because when you square a negative, it turns to a positive. So A and D aren't going to work because they're the same numbers. So it leaves us to B or C. Well, let's try B. We plug B in. 13 squared plus 0 squared equals 169. Well, 13 squared is 169. 0 squared is 0. When you combine those, you get 169 equals 169. So we want one that does not fit. That one does. By process of elimination, that leaves us with C. And just to verify, if we take 7 and plug it in, and we take 10 and plug it in, 7 squared is 49. 10 is 100. Well, 49 plus 100 is 149. That does not equal 169. Those aren't the same. Because they're not the same, that one would not fit on the graph, and that's what we want.